take down this problem. Incremental fuel costs are given in rupees per megawatt for two generating units in a plant are given by C1 dash is equal to 0.15 P1 plus 25 C2 dash, that is cost function 2. That is differentiation, C2 dash differentiation 0.12 P2 plus 15. The minimum and maximum loads on the each units are to be 20 megawatt and 125 megawatt respectively. Determine allocation of the load between units for minimum cost and load is 150 megawatt. So demand, maximum demand PD is equal to 150 megawatt. Assume both units are operating. So that is given in the problem. Now, what we need to do? So we need to find out the P1, like P1 and P2. So what they are asking is we need to find. So here, this kind of problem is given. First, you need to see the fuel cost function. Okay, incremental fuel cost. Incremental fuel cost here, they are given as a differentiation. That is dash, C1 dash and C2 dash. So in the problems that we have seen before, that C1 and C2 directly given. So here differentiation is given. So you need to be very careful while solving this problem. If you just didn't notice this, it is not differentiation directly. If you solve the problem, the answer will be wrong. So if you solve this method with the lambda iteration method, you'll get wrong answer. So always you need to see whether the problem that is cost function, it is there in the differentiation or directly it is given. So here differentiation it is given. So demand PD is it is given as 150 megawatt, and for all the generating, for each generating units, the generator limits also they have given, like a 20 megawatt less than or equal to PI less than or equal to 125 megawatt. So that is what they have given. That is minimum and maximum loads on each units are to be 20 megawatt and 125 megawatt. That also given. Here the cost function with differentiation is given, that is DC1 divided by DP1 is equal to 0.15 P1 plus 25. C2 dash is equal to DC2 divided by DP2 is equal to 0.12 P2 plus 50. Here, this is the general formulation already we derived. Summation I is equal to 1 to N. DCI divided by DPI is equal to lambda. That is nothing but DC1 divided by DP1 is equal to DC2 divided by DP2 is equal to lambda. So first, already that we need to equate to lambda. Already in this format only given in the problem. So that we need to equate it to lambda. That is the first cost, incremental cost with respect to P1, that equals to lambda. That is 0.15 P1 plus 25 is equal to lambda. So from this we can find out P1. So P1 is equal to lambda minus 25 divided by 0.15. That is that you can take it as equation number 1. Similarly, this fuel cost function 2 with respect to P2, that is also given in the problem. That is 0.12 P2 plus 15. That is equal to lambda. So from this we can easily find out P2. So P2 is equal to lambda minus 15 divided by 0.12. This we are taking as 2. That is P1 we are taking as equation number 1. P2 we are taking as equation number 2. So what is the demand given in the problem is 150 megawatt. That is nothing but P1 plus P2 is equal to 150 megawatt. So demand is nothing but generation. That is power balance constraints. Demand generation is equal to demand plus losses. So here losses is not given. So directly demand we are taking. So generation is equal to demand. Generation is nothing but what are all the generating units involved in that particular given problem. So only 2 generators are given. So we have taken as P1 plus P2, that is equal to 150 megawatt. So that we are taking as equation number 3. Now substitute P1 and P2, that is equation number 1 and 2 in equation number 3. You can find out the lambda. So here we are substituting P1, we are substituting equation 1, and P2 we are substituting equation 2 in equation 3. Now after simplifying with the scientific calculator, we are getting the lambda value. We are getting the lambda value as lambda is equal to 29.4446. After decimal, 4 digits I have taken. So here, this is the value of lambda I got. Lambda is equal to 29.4446. This is the lambda. Now you need to substitute lambda in equation number 1 to find out P1. So P1 is equal to lambda we are substituting here, and while solving using scientific calculator, we are getting the answer as P1 is equal to 29.631 megawatt. Similarly, substitute the value of lambda in equation 2. We are getting the P2 as 120.3716 megawatt. So you just tell in comment whether you got the same answer, like lambda, P1 and P2, the same values or not. Now substitute P1 and P2 in equation number 3 to check whether it is satisfying the demand or not. Yeah, it is satisfying the demand. Approximately we are getting 150 megawatt. That is 150.002 something we are getting, approximately equal to 150 megawatt. So you need to write the conclusion. So P1 and P2 satisfies the load demand or power demand, and also that is you need to take out the answer like this, and you need to write in the units are very important. That is 29.631 megawatt. Here P2 is equal to 120.3716 megawatt, and minimum and maximum operating limits are given in the problem as 20 megawatt less than or equal to PI less than or equal to 125 megawatt. PI means, so P1 and P2, both generating units should be within this limit. Yeah, now it is within this limit. Now you need to write the conclusion like also it satisfies the minimum and maximum operating limits. So if it is asked in the 5-mark question, so if you stop up to here, only 3 marks only will be given. So you need to write the answer and also check whether it is that whatever the answer we got, that is P1 generating units P1 and P2, that should be within the minimum and maximum operating limits, and conclusion you need to conclude. So that then only you will get the full mark in your exams.